Hi, welcome to the video. My name is Pushpinder Gill, and today we are going to do limits. So we can starting with our calculus course here. So this would be the web address to explore more about us. That is profit-scores.com. This would be the Facebook page to give us your valuable like, and this would be the page to give us your valuable feedback. The email address that is perfectscores89@gmail.com. Okay. So let's go ahead and get started. So I'm going to start with the function, simply going to start with the function that f of x is equal to x squared, right? So if I kind of draw this function on a graph, this is how the function looks like. Now, as you can see, this is f of x and this is x. As you can see that as x tends to 0, right, as the value of x tends to 0, the value of f of x also tends to 0. Right? I don't want to be completely at 0, but I want to say that as the value of x tends to 0, as x proceeds towards 0, then the value of f of x is also equal to 0. And this is what I am interested in here. I want to say that if you limit x to 0, then what will f of x become? F of x will become 0, right? So this is how you denote a limit. You say that general notation of a limit is that this is limit. You can write lim, and you have your variable here. Let's suppose x. If that tends to a number, let's suppose it can be a as well, then f of x will be equal to what? Right? So this is how you denote a limit. A limit kind of tests that if the value of x tends to this, then what will this function become? Right? So this is what the general meaning of a limit is. Now let's move forward to the next one. Now you've got two types of limits. You've got the left limit and you've got the right limit. When I say left limit or right limit, what do I mean by that? Let's suppose if I want to talk about this function here, right? Now the left limit is when the value of x approaches the value required from the left, and the right limit is when the value of x approaches the value required from the right. Now let's suppose if I want to evaluate the limit of this function when x tends to 0. Now there would be two limits here. That would be the left limit when x tends to 0 from the left hand side. So if I draw the number line and this is 0, as you can clearly see in this function here that when x is less than equal to 0, that is when x is actually approaching the function from the left hand side, then the value of f of x is 1. That means limit of x negative of f of x is going to be equal to 1. And when I talk about the right hand limit, that is f of x that is supposed to be reaching 0 from the right hand side, that is from this side, that is x greater than 0, then the value of this limit is actually equal to 2. Right? So this over here is known as the left hand limit, and this over here is known as the right hand limit. Now, what is the importance of the left hand limit and the right hand limit? Now, the limit exists only if the left hand limit is equal to the right hand limit. So limit will exist only if the left hand limit is equal to the right hand limit. So if I say the limit x tends to 0 negative f of x, if it's equal to limit x tends to 0 positive of f of x, then only the limit will exist. Otherwise the limit will not exist at all, because you need to have, let's suppose if I talk this function, right? So the left hand limit is actually equal to the right hand limit, because this over here is a continuous function, right? So it kind of continues that. But if I say this is a function, fine. Now over here the left, and when I talk about f of x, limit f of x when x tends to 0, this limit does not exist. Why? Because when we approach the function from the left hand side, we get a different value of f of x, and when we approach the function from the right hand side, we get a different value for f of x. That means every time we get a different value, that means this limit does not exist. So the limit is going to exist only if the left hand limit is equal to the right hand limit. So that is actually a very, very important part here. Let's talk more. Now let's see what arithmetic calculations we can operate on limits. So limit of x tends to, let's say, a, and f of x, let's suppose we have two functions, f of x plus g of x. I can write this as limit x tends to a of f of x plus limit x tends to a of g of x. Similarly, I can do subtraction as well. I can say limit x tends to a of f of x minus g of x would be equal to limit x tends to a of f of x minus limit x tends to a of g of x, right? Similarly, you can do a multiplication on limit as well. You can say limit x tends to a of f of x into g of x is equal to limit x tends to a of f of x times limit x tends to a of g of x. Same goes for division as well, that limit x tends to a of f of x divided by g of x is going to be equal to limit x tends to a f of x divided by limit x tends to a of g of x, right? So all the four mathematical functions are followed by the limit, something that would be very, very valuable to you when you plan to solve some questions related to the limit part. Alright, now what is limit of a constant? A limit of a constant is always equal to 1. So if I say limit x tends to 0 of 2x, that will actually become 2 into limit x tends to 0 of x. This 2 can be taken outside because this is a constant. So limit is only for variables, it's not for constants, right? So this is something they have to take care of. If you get limit x tends to 0 of 2, then that simply would be equal to 2, right? So because there's no x there, so you can completely ignore the limit part then if there's no variable in your equation there. Fine. So I suppose that's pretty clear too. Moving forward. Okay, now let's talk about some special limits. Something that will save you a lot of time, some manipulations that you need to know beforehand. So I'm going to do this manipulation with you. Now what I'm going to do is I'm going to divide x to the power n and a to the power n by x minus a. So I'm going to multiply this by x to the power n minus 1. Or in fact there is actually a better way of doing that. Just a second. The better way of doing this is what is x square minus a square? That is x plus x minus a into x plus a. What is x cube minus a cube? That is x minus a into x square plus ax plus a square. And what is x to the power 4 minus a to the power 4? That is going to be x minus a into x to the power 3 plus a x square plus a square x plus a cube. Now how do I know this? I haven't crammed this x to the power 4 minus y to the power 4. How am I knowing this? Because I can say that x to the power n minus a to the power n is equal to x minus a times x to the power n minus 1 into a to the power 0 plus x to the power n minus 2 into a to the power 1 plus x to the power n minus 3 into a to the power 2 all the way till x to the power 0 into a to the power n. So this is something that I can say here, that this would be the total, the value for x to the power n minus a to the power n. And if I kind of limit this, if I take this to this side and I put a limit there, that is limit x to the power a, then what will I get, right? So what will I do is I'll just plug in the value of x to be equal to a. The limit x to the power a would be equal to a to the power n minus 1 plus a to the power n minus 2 into a to the power 1 plus a to the power n minus 3 into a to the power 2 going on till plus a to the power 0 into a to the power n. So this is nothing but a to the power n minus 1, and sorry, this is n minus 1 because it's actually starting from 0, right? So which is why this would be n minus 1. This is going to be equal to a to the power n minus 2 plus 1, that is a to the power n minus 1. Then again a to the power n minus 1 all the way till a to the power n minus 1. This is going to be n times, so this whole, there are n times, this is going to be n times a to the power n minus 1. So I can say that limit x tends to a into x to the power n minus a to the power n over x minus a is equal to n into a to the power n minus 1. So suppose you're understanding what I'm trying to do here. I'll just go through the whole thing again. See, x square minus a square is x minus a into a plus a. X cube minus a cube is x minus a into this. X to the power 4 is this into this. So you can see that x power is reducing by 1 throughout, and a's power is increasing by 1 throughout. So x to the power n minus a to the power n can be written as x minus a into x to the power n minus 1 into a to the power 0 plus x to the power n minus 2 into a to the power 1 plus x to the power n minus 3 into a to the power 2, and so on till x to the power 0 into a to the power n minus 1. Now since we're calculating the limit of x being close to a, so what we'll do is we'll plug in a wherever we have x. So we get this, and that is nothing but each term is a to the power n minus 1, each term is a to the power n minus 1, that is n times a to the power n minus 1, which means limit of x tends to a to x to the power n minus a to the power n over x minus a is equal to n to the power n into a to the power n minus 1. Let's do a question on that. Let's evaluate this limit right here. So limit x tends to 0 of 1 plus x minus 1 over x. So I can write this x as 1 plus x minus 1. So this is going to be limit x tends to 0 of 1 plus x raised to the power 1 by 2 minus 1 raised to the power 1 by 2 divided by 1 plus x minus 1. So if I kind of compare this of limit x to the power x being with the x being tending to a and x to the power n minus a to the power n divided by x minus a is equal to n into a to the power n minus 1. If I've got to do that, then I have to change this part as well. So what I'm going to do is I'm going to substitute 1 plus x to be equal to y. Now if x is tending to 0, then y will tend till 1, because if this is supposed to be 0, this is supposed to be 1. That means limit y tending to 1 is equal to, now this whole is y raised to power 1 by 2 minus 1, sorry, into y raised to power n minus 2 by 1 divided by y minus 1. So this is going to be n is nothing but 1 by 2 into a is nothing but 1 raised to the power n minus 1. So that is going to be raised to the power n minus 1, which is going to be equal to 1 by 2 minus 1. So which is going to be 1 by 2 into 1 raised to the power minus 1 by 2, which is going to be equal to 1 by 2. So suppose you're understanding my point over here, right? The only thing that we did was we kind of first brought this into this kind of expression, right? And then we changed this by substituting x to x plus 1 is equal to y. So if x is tending to 0, y will be tending to 1. Right? So suppose you're understanding what we're trying to do here. Moving on to the next part. So again, this is again a special limit, right? So just to evaluate this, just to prove this, I'm going to do one thing. I'm going to draw a circle here, right, with the radius 1. So that means, let's say this is the center of the circle. This radius is 1 here. And I'm going to draw a triangle here. So this is 1 and this is also 1 because they both are the radius of the triangle. I'm going to extend this triangle like this. Now, this is 1 and this is also 1. Fine. And let's suppose this angle is x degrees. Okay, let's not make it like this. 1 second. Let's say this over here is my circle, and this is the radius, which is 1. This is the radius, which is 1, and I'm gonna have a triangle like this and a triangle like this, right? So this whole radius is 1, and let's suppose this is x degrees. So I'm gonna label them A, B, C, D, and E, right? Just for the sake of simplicity, I'm gonna label them that. So if I talk about these two triangles, and if I talk about this triangle, that is A, B, and E, in that part, you know that this is 1 and this is x, right? So what is going to be this part here, right? So what is going to be this height over here? So what is the area of a triangle? Area of a triangle is equal to half into base into height. So I'm just going to keep this formula right here. And my formula sheet, I'm going to say that sine of x is going to be perpendicular divided by hypotenuse, and tan of x is going to be equal to perpendicular divided by base. So what is sine of x here? Sine of x is equal to that is equal to perpendicular, which is this perpendicular, divided by hypotenuse, which is equal to 1. That means I can say that the perpendicular is equal to sine x. That means I can say that this is equal to sine x. Similarly, if I talk about this bigger triangle, I talk about this triangle A, C, and D, then this is definitely 1, and this is x degrees. From there, I can say that tan of x, tangent of x, is equal to perpendicular divided by base. So again, perpendicular divided by base is equal to tangent of x, which means this is equal to tan x. Fine. So this is something there which has been established now, that if I draw these triangles again like this, I would say this is x degrees, and this is A, and this is C, and this is D, and this is E. So this is sine x, and this is tangent x. I'm going to start with an identity here. That identity is that the area of ADC, which is this bigger triangle, is greater than the area of the arc of the sector of the circle of A, E, and C, which is kind of like this area, which is greater than the area of AEB, right? So if you see this, this is how things are. This is the arc of the circle and all that. So this whole big area is greater than this area, which is greater than this area, right? So this is what do we have. And the area of ADC is greater than area of arc AEC and the area of the triangle AEB. So what is the area of AEC? Area of ADC is half base into height, which is going to be half into base. The base of this triangle is 1 into height. The height of this triangle is tan x. It's greater than the area of the sector of this. So area of the sector can be given as, so I'm going to write that formula right here. Area of the sector is equal to x, that is the angle made at the center, divided by 2 pi into pi r square. We can even call it x by 360 into pi r square, right? So I'm going to call it x by 2 pi into pi r square, which is pi into 1 square, which is going to be greater than the area of AEB, which is going to be half into base. So the base is equal to 1 into height, which is equal to sine x. So this pi and this pi is going to cancel out, and this 2 is going to go away. So I'll have tangent of x is greater than x, which is greater than sine x. Okay, so what I'm going to do is I'm going to open this up, because tangent of x can be written as cosine of x by sine of x, which is greater than x, which is greater than sine of x. And we're going to assume that the area is going to remain positive, right? Because area is always positive. So we're going to take everything to be positive. So what we're going to do over here, I'm sorry, this is sine x over cos x. Sorry about that. I'm just going to write it again. Sine x over cos x is greater than x, which is greater than sine x. So what I'm going to do is I'm going to divide the whole thing by sine x. If I divide everything by sine x, I'm going to get this and this and this. So I can eliminate from here, I can eliminate this sine x by sine x and this sine x by sine x. I'm going to say 1 by cos x is greater than x over sine x is greater than 1. So what I'm going to do now is I'm going to revert this inequality. I'm just going to bring the denominators to the numerators and bring the numerators to denominators, which would actually change these signs completely, right? So from here I'm going to get cos x to be less than, this is going to get reverted, which is going to be x by sine x, which is less than 1. Now if I kind of apply limit everywhere, right, if I kind of say the limit of cos x when x tends to 0 is lesser than limit of x over sine x, that means x tends to 0, it's going to be less than limit of x tends to 0 for 1 is going to be 1 only, right? So from here, which is a little cluttered here, we can say that if I want to just clear some space out, so this is what we get completely, that is limit of x tends to 0 of cos x is less than limit of x tends to 0 of sine x over x, which is lesser than 1. Now what is this value? Now if I kind of plug in the value of x into this, that is going to be limit of x tends to 0 of cos of 0, which is lesser than limit x tends to 0 of sine x over x, which is less than 1. So cos of 0 is nothing but 1. So this is going to be 1. It's less than, because this is equal to 1. Limit x tends to 0 of sine x over x, which is less than 1. Now what is something which is less than 1 and greater than 1? Well, the value of sine x is going to be equal to 1, which means I can say that the limit x tends to 0 of sine x over x is equal to 1, right? So that is what is there. If you kind of have used the graph calculator, if you even use the graph of let's suppose if I want to do it this way, if I say that, let's say f of x is equal to sine x over x and h of x is equal to cos of x, then the value of this function is going to go like this. This is what is going to be sine x by x, and this is what it's going to be cos x by x. So when x tends to 0, right, when the value of x tends to 0, the function is going to be almost equal to 1, right? And always the cosine of x will always remain smaller than the sine of x only when the value of x is equal to 0. That is the only value where they tend, where the limit to be equal, right? So they almost tend to be equal. I might have drawn this a little not scaled to to the actual diagram, but this is going to be the function of f of x, and this is going to be the function of h of x, right? So suppose what I'm trying to say, what at the end what I want to say is that this is a special limit, that limit of x tends to 0 is sine of x over x, which is equal to 1. This is something that will lead to a lot more different things going forward. So suppose you're understanding this, moving forward to the next one. Now one more thing that you have to understand, since we took the area to be positive, we will have to take the value of x to be greater than 0. Remember we drew the value of x here. This was x. We have to take the value of x to be between this range only, because we have to take the area to be positive. So we're just going to take the value of x to be between these two numbers. Okay, now let's move forward to the next one, right? So we're going to get this one there. So now, as you recall, the trigonometric functions, 1 minus cosine of x is equal to 2 sine square x by 2. Fine. So that is what it is equal to. Substituting this into this limit, that is limit x tends to 0 into 2 into sine square x by 2 over x. Now this, I can bring this to right down here. I can say limit x tends to 0 to sine square x by 2 over x by 2, which I can actually further break down. I can say that limit x tends to 0 into sine x by 2 over x by 2 into limit x tends to 0 into x sine of x by 2. I kind of broke this sine x by 2 into sine x by 2 into sine x by 2, right? So as we substitute the value of x to be here, now since we know that this is something which is already equal to 1, as you know that that limit x tends to 0, sine of x over x is equal to 1. So this is something which is equal to 1, and this is something which is equal to 0, because I substitute x to be equal to 0, sine of 0 is going to be 0. So that is going to be 0, which means I can say that limit of x tends to 0 into 1 minus cos sine of x over x is going to be equal to 0. So suppose you're understanding what I'm trying to say here. So let's hold on. So let's kind of summarize what we did. We started with limits, right? And we can actually add, subtract, multiply, or even divide a limit the way we want. And we did some special limits, that is limit of x being tending to a, that is x to the power n minus a to the power n over x minus a is equal to n into a to the power n minus 1. And we also say that limit x tending to 0 sine x over x is equal to 1. And the second was limit x tending to 0 1 minus cos x over x is equal to 0, right? So that is what we have done, which is going to be the first part of our limits here. I suppose you're understanding what we're trying to establish here. Going forward, we're going to be doing a lot more in limits. We'll be learning how to use these into different tough questions, and learning a lot more about limits and then more about calculus. So this will be about the video, guys. Thank you very much, and I'll see you in the next one.